Okay, this next part, we're talking about these things called reciprocal trig functions. These are ones that I'm guessing fewer of you have seen. Talking about these, we got 3 new terms: cosecant, secant, and cotangent. So cosecant of an angle theta is the reciprocal of the sine. Reciprocal, remember that's flipping the fraction over. So sine, take the reciprocal of it, it'd be 1 over sine. So thinking about that in terms of opposite, adjacent, hypotenuse, if sine is opposite over hypotenuse, cosecant would be the reciprocal, would be hypotenuse over opposite. Secant, abbreviated SEC, is the reciprocal of cosine. So if cosine is adjacent over hypotenuse, secant would be hypotenuse over adjacent. Cotangent, abbreviated COT, is the reciprocal of tangent. So tangent's opposite over adjacent, so the reciprocal would be adjacent over opposite. Now, in my opinion, it'd be easier if cosecant matched up with cosine, secant matched up with sine. Unfortunately, they do not. I will slip up every once in a while and mistake them. So cosecant, CSC is connected with sine. Secant, SEC, is connected with cosine. Cotangent, that one's a little more straightforward. That's connected with tangent. One way that the textbook suggested that people remember this is like each pair has one co in it. Personally, I don't think it's very effective, but let me talk about how they used it. This is probably like worse than their attempt at a rhyme with add to x go left. So if any of you want to make a song explaining this, I won't complain. Feel free to share it with me. Maybe I'll share it with the class. But looking at these, so cosecant is 1 over sine, secant is 1 over cosine, cotangent is 1 over tangent. They each have one co in it. Quite frankly, I've never found that super helpful. If it helps you, great. For many of us, myself included, it's just kind of a matter of memorizing. Figure out what tricks or what's going to work best for you, whether it's just straight memorization that cosecant matches up with sine, secant matches up with cosine, cotangent matches up with tangent, or some other combination or some other phrasing or whatever you want to do. Awesome. If you think of any cool new ways, let me know. Taking a look at this triangle here. This triangle, we've got we're asked to find the value of the 6 trig functions. So we're asked to find sine, cosine, and tangent of the angle theta. So let's start with the sine of theta. And then we'll do cosine of theta. And then we'll do the tangent of theta. Leave some room off to the right of that. We're going to do the work for the other 3 in a second. So the sine of an angle is the opposite side over the adjacent side. So here's our angle. We're working down here. The opposite side is over here. Sorry, what did I say? Opposite over adjacent? Goodness gracious. Opposite over hypotenuse. The hypotenuse is over here. So I've taken the opposite side, 80. We got to divide by the hypotenuse, which isn't there. Now, if we were in class, I would probably stand there for a minute and look perplexed at the screen and then turn to the class and say, like, what do we do? And then eventually somebody would raise their hand and be like, oh, good old Pythagoras, the cult leader. He had a theorem about this. The theorem that Pythagoras came up with was a squared plus b squared equals c squared. The square of one leg plus the square of the other leg is equal to the square of the hypotenuse, assuming we're working with the right triangle. So let's use a, b, and c, or use a and b. So I'll just call 80a because we're already using that number. The other leg, 18, we're going to square that, equals c squared. 80 squared, 6,400. 18 squared, we all know is 324. I'm just kidding. Most of us don't go that high in terms of our squared memorizations. Quite frankly, I don't know either. Equals c squared. Keeping that together, or keep going on that. 6,400 plus 324 is 6,724 equals c squared. Now, I don't want c squared, I want c, so let's take the square root of both sides. And the square root of c squared is just c, and the square root of 6,724 is clearly 82. We all knew that, right? Yeah, of course. So, our hypotenuse length, 82. Folks, calculators are your friends. I didn't do that in my head. In fact, I'm looking at my old answer key, just because that's a large square root. So, we got 80 over 82. Now, both of those are reducible. We can divide both of those by 2, and we get 40 over 41. The cosine. The cosine is the adjacent side, 18. divided by the hypotenuse, 18 over 82. Divide both of those by 2. We got 9 over 41. Tangent, the opposite side, which is 80, over the adjacent side, which is 18. Both of those divisible by 2, we get 40 over 9. Sorry, I never labeled the adjacent side. I labeled the opposite hypotenuse. I never labeled the adjacent. Okay. Cosecant. I want to put that one over to the right of sine. The cosecant of our angle theta is the hypotenuse, 82, over the adjacent, 80. Both of those are divisible by 2. We get 40 over 41. No, sorry. Goodness gracious, that was sine. 41 over 40. There's a reason I accidentally made that mistake. Because we just take whatever we got for sine and flip it. They're reciprocals. So these are called reciprocal trig functions. You take the reciprocal of sine, you get cosecant. So the one that goes along with cosine is secant of angle theta equals, well, it's the reciprocal of cosine, so it's 41 over 9. Cotangent, COT, is the reciprocal of tangent. So the cotangent of angle theta is going to be 9 over 40. Once you find the first three, just flip them to get the other three. That's all.